All right, here we go. So 128 parent function book part 1. This is our review piece. So we're going to review constant, linear, quadratic, and square root. Okay. Do all those names sound familiar? I hope they do. So to start, we're going to start with the constant function. So your constant function is f of x equals c, or not as fancy, just y equals c. So it's just y equals a number. It's going to create a horizontal line. Do we see the horizontal line? Okay. So for this one, this line is y equals 2. Okay. So this is y equals 2. And now we're going to describe the domain. So from left to right, what is happening? All real numbers, right? It's all real numbers. It goes from negative infinity to positive infinity. What about my range? For this graph, so your range is whatever your C value is. But for this graph, it is y equals 2. That's all. Y is nothing else but 2. Do I have any other y values? No, I do not. Okay. Your x-intercept, in order for this to be a function, there is not an x-intercept. Your y-intercept is always 0, comma, the C value, whatever the constant is. So for this graph, what is our y-intercept? 0, comma, 2. All right. There is no asymptote. There's no maximum asymptote. What type of symmetry do you think this graph has? It has reflectional. That's because the y-axis evenly divides it. Do we see that? A little bit of both. All right. Inverse function. Okay. It does not. There is no inverse function. Okay. The reason why there is not an inverse function is because what's the opposite of being horizontal? Vertical. And are vertical lines a function? No, they're not, because you have your x's are going to repeat, right? All right, so that's constant. On to the classic linear. No. Linear, f of x equals x. Okay. That's the parent function. You guys are probably used to saying y equals mx plus b. That's our slope-intercept form. But the parent function is just f of x equals x, or lazily, y equals x. Okay. The domain of this function is all real numbers, right? It goes from negative infinity to positive infinity. And the same for the range, because it goes on forever to the bottom and forever to the top. My x and my y-intercept are both at the origin. We still do not have an asymptote. An asymptote, if you recall, is an imaginary boundary line. It's like saying this function is getting close, 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 but it never will touch it. If I'm going on forever, do I have a maximum or a minimum? No. Ooh, what type of symmetry do you think exists? It's rotational. If I was to rotate this 180 degrees, it would look the same. The other one technically, no, because it would be in the other quadrants. But if I rotate this one 180 degrees, it would be exactly the same. Turn your paper 108 upside down. Turn your paper upside down. Exactly. That's what makes it rotational. Oh, the first one, they're not the same thing. The lines in the, you go from being in quadrants 1 and 2 to being in quadrants 3 and 4. Is that the same thing?
No.
It is not. Okay. All right. The inverse function is, guess what? Itself. The inverse function here is itself. The inverse for this function is itself. It's its own inverse. And we'll learn why a little bit later in section 1.4. Okay. Inverse just means that you're substituting in your x for your y. And if your x and y are constantly the same value, it doesn't make a difference. All right, next, quadratic. So we're at the quadratic. F of x equals x squared, or lazily y equals x squared. The quadratic makes what's called a parabola, right? Parabola. That's how you spell it. I'm fixing it. Parabola. It is spelled like parabola. Parabola. Okay. So for the parabola, what is my domain? What's happening from left to right? Infinity. It goes on. That's a horrible infinity symbol. Who did that? Oh, it's gonna be as good as kids. All right. However, what about my range? What's happening with my range? My range is y has to be greater than or equal to 0, or from 0 to infinity. It is a bracket on the left. My x and y intercept are the same. So we're at 0, 0, and I still do not have an asymptote. Does this have a maximum point? No, because it's going to infinity and beyond. Do I have a minimum? Yes, my minimum is at x equals 0. Yeah, I don't post them. It's too hard to manage the student council one and teacher one. It became too much. One of them was going down. All right, so symmetry here. Reflectional. That's because, again, the y-axis evenly divides it. Do you see that? All right. What is the opposite of squaring something? Square root. Okay. You're the third person to give that lame joke, by the way, Isaac. Yeah. The opposite of squaring something is to circle it. Yeah. Third person today. So the inverse equals the square root of x. All right. Questions about the quadratic? All right, you just got one more to do, which is the square root. So we have f of x equals the square root of x. Now, here we have a defined starting point, right? So our domain is x is greater than or equal to 0, which means it starts at 0 and goes to infinity. Our range also starts there. So we have y is greater than or equal to 0. Do we all understand those both notations? Questions about either notation? Okay. And x and y intercept are at the same location. All right. All right. There's no asymptote. There's no maximum. And the thing here is, technically by definition, we don't have a minimum, but we have a minimum value. And our minimum value is at x equals 0. What type of symmetry? Is there any? No. And its inverse function is the opposite behavior. What's the opposite of square rooting something? Squaring it. So we write inverse equals x squared. Okay. So that concludes the first third of our parent function book. What you're going to be working on to the end of the class is using those notes to answer the exit ticket. Okay. All right, so you're gonna be working on this exit ticket for the remainder of the class period.
You want to do an outro?